Hello everyone, my name is Luisa Machado, and our team's project is Political Leaning Classification of News Articles using NLP. Today I'll be walking you through the introduction and the motivation behind our work. Let me start briefly by outlining today's agenda, so that way you have a clear sense of how this presentation will flow. First, I'll begin with an introduction where I'll provide context on the problem we're addressing and why it's relevant in today's information landscape. Then I'll move into the motivation behind this project, focusing on the challenges of identifying political bias in news articles and why developing an automated solution is both necessary and impactful. And then the remaining sections we have are methodology, results and evaluation, and the final demonstration. This will be covered by my teammates, Sandra and Anthony. With that overview in mind, let's begin with the introduction. To kick off the introduction, I want to start with something we all experience, even if we don't always notice it right away, and that is media bias. According to research on this topic, such as a systematic review on media bias detection, today's digital environment exposes us to a huge volume of information. But that does not necessarily mean better understanding. A large portion of this information is influenced by ideological perspective, which is what we refer to as media bias, which refers to the presence of an ideological perspective in news reporting, and it can appear through word choice, framing of events, or selection of facts. For example, imagine two articles covering the same political decision or the same political event. One might describe it as necessary and beneficial, while another might call it controversial and harmful. Even though the event is the same, the wording changes how we interpret it. The research also highlights that people tend to favor information that aligns with their existing beliefs, creating what are called information bubbles. This reinforces bias and makes it harder to see multiple perspectives. So that's exactly what our project focuses on. We built a system using natural language processing, or NLP, to automatically classify news articles into political categories: left, center, or right. In our approach, we compare traditional machine learning models with transformer-based models. On the traditional side, we use TF-IDF features with logistic regression and support vector machines. On the advanced side, we use transformer-based model called Dilbert, which captures deeper context in language. The main challenge we're addressing is that identifying bias manually is not practical. It is time-consuming because there are thousands of articles. It is subjective because different people interpret bias differently, and it is not scalable for real-world applications. Because of this, our goal is to build an automated classifier that can detect political ideology using NLP. The final output of our system is a predicted label for each article: left, center, or right. So overall, we're building on existing research and creating a system that provides a scalable and consistent way to analyze media bias. With that overview, I will now move into why this problem is important. Now, let's talk about the motivation behind this project. Today, we are constantly exposed to news through social media, websites, and digital platforms. At the same time, there has been a clear increase in propaganda, false or misleading information, and politically unfair content. Because of this, it's becoming harder for people to distinguish between a neutral reporting and biased information. This directly affects how people form opinions and understand the news. For example, if someone consistently reads content from only one perspective, they may not even realize that alternative viewpoints exist. Now, one possible approach will be to manually analyze articles, but in reality, that's not effective. First, because it is time consuming, since each article must be reviewed individually. And also because it is subjective, because different people may interpret the same content differently. So there is a clear need for an automated approach. An NLP based system allows us to analyze large datasets efficiently and provide consistent predictions. This means that it can scale to large amounts of data while reducing variability in results. There are also important real world applications. For example, it can be used for media monitoring, where organizations track how different sources report on the same topic. It can support fact checking systems by identifying potentially biased contents that need further review. And it can be used in recommendation systems to help users access more balanced information. So, overall, the goal is to create a more efficient, scalable, and consistent way to analyze political bias in news articles. And that's why building an automated solution like this is so valuable today. Now I'll pass it to Anthony to continue the presentation.
Starting with our literature review. We started by reviewing existing research on political bias in text. Earlier approaches mainly relied on traditional machine learning models like logistic regression and XVM using such features as TF-IDF. The method worked reasonably well, but they treat text as collection of words and ignore deeper context. Into the transition, more recent work, especially models like the BERT, the polybird torch, use transformer architecture which capture contextual meaning and relationship between words. This model consistently achieves better performance because political bias is often subtle. It's not just about what words are used, but how they are used, and sometimes ambiguities and favoritisms. However, we also identify key challenges in the literature, including limited explanatories and data set bias, which can affect the model reliability and performance. Our methodology follows a complete NLP pipeline from raw data to final prediction. We use the article bias prediction dataset from GitHub, which contains around 37,000 labeled news articles categorized as left, center, or right, using numbers to represent the left, the center, and the right. Our data set was stored in JSON format. We first extracted the full article text by combining fields like the title and the content. To connect with our code, we implemented a custom function to clean and merge the fields into a single text input. Our train or test split, we use pre-train validation text split to ensure fair evaluation. For traditional models, we use TF-ID to convert these numerical features using unigram and biagram under the feature engineering. On the model training, we train two types of models: the classical machine learning model, the transformer-based deep learning model, and we evaluated all models using accuracy, recall, precision, macro F1 score to ensure balanced performance across all featured classes. This pipeline allowed us to fairly compare simple models with more advanced transformer-based approaches. Next slide. The model applied. We implemented both pipelines and advanced models to compare performance. The base model we used were the logistic regression and XVM. The logistic regression, this is a simple linear classifier that served as a strong baseline for our test classification tasks. The XVM improved on this by finding an optimal or accurate boundary between classes, which often perform well in high-dimensional data, text data. On our advanced model, we featured the distal BERT. We then use this model, which is a lightweight version of the BERT. Unlike the TF-IDF, this model understands the context of words within a sentence, making it more effective for detecting subtle political biases. This allowed us to directly compare traditional feature-based learning with modern contextual language model. In short, TF-ID model focuses on word frequency, and distal BERT focuses on meaning and context. With a system architecture, our system architecture is designed as a simple pipeline. The system takes a raw news article as input, and with the pre-processing, the text is clean and prepared for analysis. The feature extraction that we implemented, depending on the model, like the TF-IDF, convert text into numerical vectors. The distal BERT generates contextual embeddings. And with the model layer, the processed data is then passed into one of the trained models, such as the logistic regression, the XVM, or the distal BERT. And our final output, the system outputs a predicted political label, left, center, or right. This modular design makes the system flexible. We can easily swap models or extend it with more advanced techniques. Thank you. The results and evaluation continues from Sandra.
Hey, this is Sandra. I'm going to do a quick summary of overall performance of our models. For the classical approach, TF-IDF with logistic regression achieved about 68.4 accuracy and about 0.68 micro F1, while linear SVM performed slightly lower than that. With the transformer models, as you could see, the distal BERT showed a clear improvement and reached about 71.5 accuracy and 0.72 micro F1, making it the best overall. We focused on the macro F1 since it's balanced the performance across the left, center, and right, as we discussed earlier, classes rather than favoring one. Overall, the distal BERT performed best. Logistic regression was the strongest classical model, and then the main challenge was distinction of similar or like neutral articles as well. This is quick visual of our visual performance across different matrices. On the left bar chart compares the classical models where logistic regression performs slightly better than linear SVM. On the right line graph includes the distal BERT, and we can see it outperforms both the models across the matrices, especially in the macro recall and macro F1. Overall, this just shows the classical models capture his forward patterns. Distal BERT's ability to understand context leads to more balanced and accurate prediction. We're passing into the demonstration, which I'll talk more with time limitation on the demo.
Hello, everyone.